Hello students, nice to see you again. In this video, we attempt to do a whole series of solutions from the Extended Mathematics 0580 from the paper May-June 2020, paper 2, variant 2-1. All right, and we are going to break it up into 5 parts. Now we're going to start with part 1. Let's get started. Question 1. Rectangle A measures 3 cm by 8 cm and was given in the diagram 5 rectangles congruent to A are joined to make a shape. Now, what does congruent mean? It means simply exactly the same. Now we go on, work out the perimeter of this shape. Perimeter simply outline. With that notion in mind, we know that those lines shown in dotted, which is the inside, will not be included. All right, so now we're just going to carefully examine the diagram and see what can we find and gather them together wherever possible. Let's look at the 8 centimeter sides. How many of them? 1. Any more? 2, 3, 4, 5, 6. There are 6 of the 8 parts, right? 8 centimeter parts. So centimeter parts, we have 6. There we go. Now we move on to look at the 3 centimeter parts. 1, 2, 3, 4, 5, 6. That's it. That's all about it. 3 cm. We have 6 pieces of them. Then we left with some of these parts. We notice that it is very interestingly laid out. All right, the one that I put in purple. All right, but it gives us not much of trouble because we know that being congruent, in other words, this dotted line has the length of 3 centimeter. So what we do is we take the 3 centimeter out of the total 8 and evenly divided the 2. That's how we get 2.5. And then we carefully take the 2.5. We have how many of them? Now carefully counting, we have 1, 2, 3, 4, and more of them, 5, 6, 7, 8. Here we go. So putting all this thing in, punching into calculator, and you will comfortably come to conclusion of total 86 centimeter. Now we move on to question number 2. Find the highest or odd number that is a factor of 60 and a factor of 90. Now we look at the number factors of 60. Factors of 60, well, the easiest way and the safest way to list all the factors is finding the factor pairs. All right, the two numbers and multiply up to get the number that we want. Now, if we are looking for 60, we find out all the number pairs, the factor pairs, starting from the smallest factor, multiply the biggest factor, the first pair, and we list on, and on. Then we do the same thing for 90. There we go. And then do the same thing, list down the number pairs. By doing this, you are certainly assured that you miss none of the factor. And then once we've done that, what we do is you scan through all of them. Surely the first thing they put bold printed for us, odd number. We're going to look for odd, and with the second criteria, the highest odd. By scanning through, you notice that the highest odd in this case was a factor of 60 is 15. The highest factor of them is 15, and then they want that the highest odd number that is true for both numbers, 60 and 90. Therefore, we get the answer 15. And we move on. to the question. Mrs. Salaman gives her class 2 mathematics test. The scatter diagram shows information about the marks each student scored. Here it was displayed to us. A, write down the highest mark score on test 1. Okay, easily we go and mark out the axis that where test 1 is recorded. Go and all the way to look for the highest recorded score. There we go. You notice that is the 1, which is the highest. So we got that as 66. Move on. B, write down the type of correlation shown in the scattered diagram. Talking about correlation, we know that there are 3 types altogether. For the sake of revision, let's show all of them. Being scattered, meaning the dots are scattered all around. All right, it means scattered all around. All right, and then, but sometimes you notice that it's scattered, but with some kind of significant trend. And sometimes you notice that it's scattered, but somehow it shows some kind of trend. All right, so for the first one, if you look at that, if you have a scattered that seems to be all over the place, then we say there are no correlation between the two elements, okay, that we are talking about. And then when you notice there is some kind of a positive uptrend, that means it seems to going up with the gradient positive, and that we call them, that is a positive correlation. And then somehow, sometimes the scattered seems to have a downward trend, therefore we call this the negatively correlated. Now back to this question, we notice that the trend seems to going upward. So that's explain the answer as positive. Part C, draw a line of best fit on the scattered diagram. And then best fit line means a straight line, not a curve, not a curved line or freehand line. We got to get a straight rule to help us get a straight rule. And best fit just simply means as many dots as possible that is able to fall within this line. Okay, so what you can easily do is get your straight rule, go across the scattered points and try to find some place where you have almost an evenly number of dots above and almost evenly a number of dots below. And that's, you take your rule and make a straight line drawn, and you get it. That's your best fit line. Now, part D, Hamish scored a mark of 40 on test 1. He was absent for test 2. Use your line of best fit to find an estimate for his mark on test 2. Okay, now we know that the question told us that Hamish did present during his first test and he scored 40. Then by using a best fit line, we are able to predict or estimate what would he achieve. All right, so what you do is you find this 40, taking a line upward, touching onto your best fit line, and then you go horizontally to the test to exist. And the point that is pointed to, that is the estimated mark that we get for Hamish for his test 2, that we read 48. That's how we put in the 48. And if you look at the mark scheme, they allow within the range of 46 to 50. So our number 48 looks good. Okay, so now we move on to the next question. The question number 4, the bag contains blue, red, yellow, green balls only. A ball is taken from the bag at random. The table shows some information about the probabilities, and it was shown on the table. A, complete the table. All right, so we know that this is on probability, and then probability, we have when it is all completely impossible, we know that we're going to start with 0. And then as we go all the way to one condition where it is certain, we know that it's going to be 1. So as in other words, in a bag of blue, red, yellow, green balls, everything add up, we're supposed to get all of them 1. Okay, 1 where everyone is in. So now, if you have the probability to draw the blue is 0.5 and then draw the red is 0.2, then all this number add up, supposed to sum up to 1. And therefore, in order to get yellow, what you know easily, you just take the 1 and then take out all the probability of the other colors. And then you will comfortably getting 0.22 and filled in the blank there. Now part B, Abdul takes a ball at random and replaces it in the bag. He does this 20 times. Okay, how many times he expects to take a red ball? Right, so I put down here, this is one of the main and easy guide for us in order to find how many successful time that we're able to achieve. So what we do is you consider it's a similar concept with fraction. All right, so over here we will just put it out of the total of how many events. For this case, the total of 200 events. He take in 200. He attempt to take that. Then we find out what is the probability of getting red. All right, the chance is 0.2. So therefore, we take the 0.2, the chance for getting the red multiplying the total. So the successful numbers of time getting the red ball is 40 times. Yep. So now we hop on to the last questions from this part. Question number 5. Part A, the nth term of a sequence given to us 60 minus 8n. By looking at the nth term, now before I proceed, what's nth term? Nth term is simply a program or the way some series is progressing. All right, so the n, what does it tell us? N tells us the position of the number. Example, first term, we will have n equals to 1. Second term, we will have n equals to 2. Third term, n is equal to 3. So by doing that, so that's how we get that. So now, for this particular series, it says the n term that you go on is by 60 minus 8n. Find the largest number in the sequence. Okay, if you look at the 8n portion, considering when first term, that means n is 1, and then 8 times 1 is 8, 60 minus 8. And then if you look at the second term, when n is 2, so 8 times 16, so 16 minus 16, you notice the number is getting smaller, smaller, smaller. In other words, now if they are asking for the largest term, it has got to be the first term. All right, so therefore, now easily putting in, taking when n is 1, you substitute into the n term, you got 52. That's it. And then for part B, here are the first 5 terms of a different sequence, completely different. Find an expression for the n term of the sequence. All right, so if you notice that again, this what types of series is this? When you notice that they have a common different. Let me show that to us. The one that I put in green, each of them, the difference between them is +7, and that is what we call common difference. Okay, and difference, and we note it as a D. Now, with the common difference, we call them, this is an arithmetic sequence or series. Okay, but I think there must be an E, all right? Okay, then now, in order to find an n-term, you can actually use the formula that was given to us during our course. We know that for arithmetic, the formula is A1 plus n minus 1 total multiply D. So by substituting, what is A1? A1 simply means first term. Therefore, we record here, I put down here first term as 12. The D, which is the common difference, is +7. By substituting everything and you simplify them, then you get 7n plus 5. You can also write that as 5 plus 7n. And you got the full mark for this question. All right, so we will take a break from here from part 1. We will see you again in part 2. See you soon.